The second one is x greater than -2, and the last one is y less than or equal to 4. And that was going to be my first question for you. Are these linear? And the answer is yes. They are all linear. There is nothing that is not the graph that's a linear function. So you can say, why is this problem here? Because this section deals with non-linear systems. It's an exercise. Okay, so I have to start with 3x plus y equals 6, linear. When x is 0, how much is y? When x is 0, you're way ahead of me, I'm sure. Okay, so then when y is 0, x is, very good. As I said, you're way ahead of me. The order is not important. I mean, you can find the x-intercept first and then the y doesn't matter. Okay, so this is a line. I'm going to graph it by plotting the 2 points. So 0, 6, 1, 2, 3, 4, 5, 6, 0, 2, 0, and this is it. Do I graph it as a solid line or not? Solid indeed. So then I write 3x plus y equals 6. I did not solve the inequality yet. This is just a graph of the equation. Okay, it divides the entire plane into 2 regions, the one below and the one above. Which ordered pair would you like to use? Please say the origin. Thank you. So I'm checking the bottom then. 0, 0, less than or equal to 6. If you say this is true, then I'm going to shade in the bottom where the origin is. If you say false, I'm going to shade in the opposite. True indeed. So this is 3x plus y less than or equal to 6. The next equation is x equals -2. How do I graph something like that? X equals -2. What type of graph will that be? Yes. Which one? Vertical line. Awesome. Very good. So is it a solid line, vertical line, or not? No. Very good. Awesome. X equals -2. There is no need when we have only one variable to plug in any point. I just have to think. X greater than -2. Which way am I going? Am I going to your right or am I going to your left? Of course, to your right. X greater than -2. At this point, I cannot move on before I intersect the orange territory with the blue territory. Do they overlap? The orange, which is this, and the blue, which is this. They do. So not points on the vertical line, not. Very, very close to them, but not. Everything on this, all points on this line, yes. And everything in between. This is first 2 inequalities. Only now I'm ready to put in the third one, which is y equals 4. How do I graph something like this? Y equals 4. Horizontal line, awesome, thank you. 1, 2, 3, 4, right here. But do I graph it as a solid line or not? Very good, awesome. So then I have y equals 4. We go up or down. I don't need points for one line that is that does not have more than one variable. So y equals 4. Y less than or equal to 4. Do we go above or we go below? Awesome. So y less than or equal to 4. Now I have to intersect the red region with this kind of a triangle. Is no way by any means a triangle, but you know what I mean, right? So do they overlap? Yes. So not points on this line, points on this line, points on this line, and everything in between. And this is all three. All three inequalities. Any questions? Any questions? As I mentioned, next week, I meant to say Tuesday and Thursday, we're going to review for this test and for the final exam as well. I set it up with the other class for May the 5th. If you could come early so we can do even more review. May the 5th is the last day of classes for us.
Yeah, so that was a Saturday because I looked at it today. Okay, so we have a test.
On May the 1st. May the 1st.
Our final the 3rd or just
No.
Then our final?
No, this is the last class and the final will be the next Tuesday.
Okay.
On May the 8th. So if you could on May the 3rd come in as early as you can, because I would like to review for the final exam. I really wanted to set up another time, some other time, like that Saturday or Friday, but nobody wanted to meet. So I said, okay. But if you want to, we'll schedule something else. Okay, so I'll remind you of that. So the last section is 8.1 that deals with sequences. And it has four specific topics. And I'm not going to present them in the order they are listed here. So I'm going to start with the factorial notation first, then the summation notation, and then these two. Okay? So let's start with the factorial notation. Factorial notation. Okay, so for example, 6 with the exclamation mark is read 6 factorial. It's a useful notation. However, we're not going to do much with it, unfortunately. It's going to be part of a next course, which you may or may not need. But we're just looking at the basics right now. What does this mean? It means 6 multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, and multiplied by 1. And very easy to plug this in the graphing calculator, if you could bear with me. So go to the graphing calculator, and let's put in 6. And then go to Math, scroll to the far right, which is Probability, and choose, what am I going to choose, you think? 4, correct? So click on 4, and you see 6 factorial. And the calculator, when I press enter, it will calculate 6 times 5 times 4 times 3 times 2 times 1. And that is the answer, 720. Any questions? Okay. Now I would like to practice this a little bit. On page 752, I would like to look at problem 26. 752. And here we are asked to evaluate each expression. So what do I see here? I see 20 factorial divided by 2 factorial multiplied by 18 factorial. Yes, I could immediately reach for the calculator and come up with crazy stuff, but let's think for a moment before we do that. Which of these two numbers is bigger? I know it's a silly question, but I'm making a point. So the bigger, the numerator, correct? 20 and 18. Which of these two? The numerator, correct? Okay, so because 20 is bigger, I'm going to present it as 20 times 19, and I should continue 18, 17, but I don't want to. I'm going to stop at 18 factorial. Why? 2 factorial is just 2, and 18 factorial, I'm not going to expand it. Why? Because I'm allowed to simplify factors. And that simplification makes the problem so much easier. I will simplify by 2. So I have 10 times 19. The answer is 190. Let's look at another one. For example, 27. In 27, you cannot even use the calculator. So understanding how these work and how to simplify them is very important. Because everyone can punch the numbers in the calculator, but understanding what's happening and where do I start and how do I simplify this is more complicated. Which of these two numbers, n plus 2 or n, is bigger? I know it sounds crazy, but that's the starting point. That's how I ask myself, which one is bigger? The numerator. Good. So how will you rewrite the numerator? You will write n plus 2 multiplied by minus 1. You have to go minus 1, minus 1, minus 1, not minus 2. Very good. N plus 1 times factorial. Very good. Why do I stop at n factorial and I don't continue with n minus 1 factorial or something else?
The next one would be 0.
No, there is no 0 here. So, okay, let's talk about this. n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, dot, 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 3 times 2 times 1. So there is no 0 anywhere. But why am I stopping at n factorial? Because I want to simplify. Exactly. So this will be, I distribute. It's n squared plus 3n plus 2. So in general, n factorial is n times n minus 1 times n minus 2 times 3 dots, 3 times 2 times 1. So whatever n is, I have to end with 1. All natural numbers multiply from, if this is 10, then I have 10, 9, 8, 7, 6, blah, 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 3, 2, 1. Is that okay? If this is 20, I have 20, 19, 18, 17, 16, 15, blah, 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 3 times 2 times 1. Is that better? Yes? Okay. Any more questions on factorials? Okay, it's just a notation. But of course, every time we invent a notation, it comes with properties, right? Okay, so let's take a look at the following. The next subtitle is Summation Notation. So we had the factorial notation and now the summation notation. What is this? Okay, it's a different way of writing something like, let's say 1 squared plus 2 squared plus 3 squared plus 3 dots, exactly 3 dots, plus n squared. This is obviously a sum of terms. 1 squared, 2 squared, 3 squared, plus dot, 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 till n squared. Okay. There is a way of rewriting this very nicely and very condensed. Very condensed. Because this is a sum, we're going to use a letter that is an S, but it's not the Latin S, but the Greek S. So we're not going to use S, but we are going to use this S. Still an S, but it's a Greek S, standing for sum. Why we prefer this symbol, you will see in a moment, because what I'm going to do to this symbol is kind of not possible to an S. Okay? So, right here under S, I have to write a lower limit. Right at the top of S, I will write an upper limit. And in front of S, right here, I'm going to present this. So the lower limit starts with what number? What is the starting point? What is the first number in the sum? 1. 1. Indeed, squared. So I equals 1. From I equals 1, then it goes to 2, then it goes to 3. Where is the upper limit for I? N, indeed. From I equals 1 through N. And what do you think I'm going to write right in front of the summation notation? Exactly what this means. It means I squared. Let's do this together. And then we're going to play with this and come up with the sum and the generic term. Okay. When I is 1, 1 squared. The sum says plus. I move on. When I is 2, 2 squared. The sum says plus. When I is 3, I move on to the next one. 3 squared. The sum says plus. Dot, 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 till I get to the very last one, when I is n, and I get n squared. Okay, what if I ask you this? 1 cubed plus 2 cubed plus 3 cubed plus dot, dot, dot plus n cubed. How will you present this using the summation notation? Instead of presenting all this, just give me the condensed form. What will you say? The sum from I equals
1.
to the upper limit maximum n or m, whatever you want to write, from
5 cubed.
that's it. That's the condensed form of all this. Let's practice this on page 752. Here's the first one, 46. 5 plus 5 squared plus 5 cubed plus dot, dot, dot plus 5 to the 12th power. They want us to use the summation notation to express this. Yes, I'm ready. Sum from I equals, exactly, I equals 1 right here. And what is the maximum? Very good. From what? If I write I, aha, 5, but if I don't have an I here, then it's not going to go from one term to the other. 5 raised to I. Let's check. Let's check. When I is 1, I get 5. Plus, when I is 2, I get plus 5 squared. Plus, because the sum. When I is 3, then I get 5 cubed. Plus, dot, dot, dot. When I is 12, I get 5 to the 12th. Is that clear?
So for the placement of the I in this case, much like the other one,
It's exactly what changes.
the changing piece is the I. That's the incremental.
That's it.
if you
That's
try
it.
to think of it.
Because here we had 1, 2, 3, not this one. This one stayed.
So
what
that's the
cha-
exponent that it was. But
Exactly.
The variable that changed is the I, the 1, 2, 3, 4, 5.
Exactly.
And then on
So
this
I
one,
can
it's-
go from the first one to the 12th one. Yes.
Would there ever be a time where I would start like on 5 squared instead of 5 to the first?
It's possible. Then you will say from I equals 2. Yeah. Very possible.
So whatever the starting number is that's changing.
That's it. That's it. That's what you're going to use.
Okay.
Very good. So let's look at 49. So here we have 1 over 2 plus 2 over 3 plus 3 over 4 plus dot, dot, dot plus 14 over 14 plus 1. How do I change this? What do I have to write first? Yes. From I equals 1. Till what? Very good. Awesome. Obviously, it's a fraction. What do I have at the top? Very good. But if I have top and bottom, then the last one is going to be 14 over 14. But it's not 14 over 14. So what do I have in the denominator? If I put 14 plus 1, or plus, what did you say?
I said I, because I equals 1.
Okay, so let's see if it works. When I equals 1, this is 1, but the bottom is 14 plus 1, which is 15. So this is not working. Good. So then I have to be able to get all those terms. Exactly. Indeed. Let's check. When I is 1, top is 1, 1 plus 1 is 2. First term is accounted for. When I is 2, 2. 2 plus 1 is 3. The second term is accounted for. When I is 3, 3. 3 plus 1 is 4. Last one, 14 at the top, 14 plus 1 at the bottom. Clear? Is that clear? Yes? Very good. Another one? Okay. Let's do 44.
So it was written differently only because the maximum limit was 14. So you had to illustrate it as 14 plus 1 instead of
The denominator,
14.
yes, because so the top is I, but at the bottom is always I plus 1. So as you see, this is 1 and this is 1 plus 1.
Yeah, I'm good all the way up until the 14. So the 14 plus 1, you can't write 15 because the limit was.
You
14.
can, but they wrote it like this to help us come up with this. If they had written 15, it would have been slightly more difficult to come
Fair
up with I plus 1.
Okay.
But yes, of course, you can write
So
15.
technically that would be 15. It's just written that way.
Absolutely.
Figure it
Just to
out.
show us what to do.
I just want to make sure that wasn't something specific that if
No.
the maximum limit.
No,
is a
it was
certain
just
way,
giving us some hint.
just making it easier. Okay.
Yeah, exactly. So 44. 1 to the 4th plus 2 to the 4th plus 3 to the 4th plus dot, dot, dot plus 12 to the 4th. They want us to condense this using the summation notation. How do I write this? So I have I equals to what? Good. From I to the 4th indeed. Let's check. When I is 1, I have 1 to the 4th, plus when I is 2, I have 2 to the 4th, plus when I is 3, I have 3 to the 4th, plus when I is 12, I have 12 to the 4th. Good? Okay, so now we are given, for example, 34. And we are told, no, they don't want I, they put in K, it doesn't matter. Same thing, I or K or J, it doesn't matter. They are giving us the summation notation and they say, find each indicated sum. So they want us to find the sum. First of all, how many terms will I have to write? Exactly, from I equals 1 to 4. Okay, do not calculate anything. I want everyone to see what you're dictating. Give me the answer for the first term. But don't calculate anything. Yes? 1 minus 3. Good.
1 plus 2.
Very good. This was the first term when K was 1. Plus
2 minus 3 plus 2.
very good. This was the second term when K was 2. Next term. 3 minus 3 and 3 plus 2. Good. Plus one more term.
4
I wanted to write them like this for everyone to see where they come from. And now we're going to calculate. Okay, 1 minus 3 is negative 2 and this is 3. Negative 2 times 3 is negative 6. 2 minus 3 is negative 1 times 4. Negative 4. This is 0 because 3 minus 3 is 0. 4 minus 3 is 1. 1 times 6 plus 6. The answer is negative 4. Okay, one more. You are going to love this one. 42. The sum from I equals 1 through 5, from I plus 2 in parentheses factorial over I factorial. How many terms do I have to present initially? And do not calculate anything at this point. 5 terms. So please dictate the first term. No calculations. Oops, I'm sorry. I meant to write the equal symbol. 1 plus 2 factorial over 1 factorial. Awesome. That was the first term. 2 plus 2 factorial over factorial plus. Very good. 3 plus 2 factorial over 3 factorial plus 2 more. 4 plus 2 factorial over 4 factorial plus 5 plus 2 indeed factorial over 5 factorial. So we got out of the summation notation. We established each and every term. We determined each and every term, and now we have to calculate. Okay. 1 plus 2 is 3 factorial. 3 factorial is 3 times 2 times 1. And 1 factorial is 1 plus. 2 plus 2 is 4 factorial, which is 4 times 3 times 2 times 1, over 2 factorial, which is 2 times 1, plus 3 plus 2 factorial, which is 5 times 4 times 3 times 2 times 1, over 3 factorial, which is 3 times 2 times 1. 2 more. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. And finally 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1 and 5 times 4 times 3 times 2 times 1. The reason I presented them like this is because they are not big numbers. Otherwise, I should have simplified them, right? Okay, so here it is. Gone gone. 1, 1. Gone, gone. 1, 1. Gone, gone. 1, 1. And then gone, gone. 1, 1. What is left from the first fraction?
Can you not get rid of the one?
Well, it turns into a 1.
Yeah.
Plus. What do we have left from the second one? Very good. Plus. What do we have left from this third one?
20.
Very good. Plus. What do we have left from the fourth one? Good. And from the last one? 42. Very good. So this is 50. So I have 50 and this is 54. That's 60. Is it 110? Correct me if I'm wrong. So I got 50, 54, 60. Is that okay? Good. 110. Any questions? Any questions? Okay, last topic. Sequences. So what is a sequence? It's a list of numbers. A1 is the first number, A2 is the second one, and A3, dot, 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 AN. AN is the general term of the sequence. Okay, write the first 4 terms. 4 terms. Write the first 4 terms of each sequence whose general term is given. Okay, I'm going to start with number 9. AN, that's the general term, equals 2n in the numerator and n plus 4 in the denominator. We're asked to identify the first 4 terms of this sequence, meaning finding A1, finding A2, finding A3, and finding A4. What does this mean? A1 means that n is,
1,
A2 means that n is,
2.
and so on and so forth. Okay, so A1, when n is 1, what would you tell me to write? 2 over 5, that's it. A2, when n is 2, what will you tell me to write? 4 over 6, which is 2/3. Perfect. A3, please. 6 divided by? It's okay. And A4, last one. Over? And I will simplify by 4, 2/3. Very good. Final. I'm sorry. Sorry. I'm sorry. Nobody's fault but mine. Sorry, sorry. Very good. 2 times 4 and 4 plus 4. Thank you. Thank you, Natalie. Okay, so last idea is a sequence can be given to us with a general term, like this one was. Can anyone give us the term before AN? It's A before N. N minus 1. If I want to create another one, the next one will be A N plus 1, and so on and so forth. Good. So, in certain situations, we are given, like, for example, problem 14. Same page, 752. We are given A1 equals 12, and we are given AN equals AN minus 1 plus 4. This is basically a relationship. This is the general term, but it's given in terms of the previous one. So we call this a recursive relationship. So it's not given directly as the general term. We are given the general term, but it depends on the previous one, which depends on the previous one, which depends on the previous one, which depends on the previous one, and so on and so forth. So we are given a relationship, not plain AN, plain general term, with no connection to other terms. But this is a connection to the previous term. Okay. So the same question we are asked to find. We're asked to find the first 4 terms of this particular sequence. So what is the first term of the sequence? That's it. What will be the second term of the sequence? The second term of the sequence depends on the first term of the sequence. So I will have to write A1 plus 4, which is 12 plus 4, which is 16. Because if this is 2, this is 2 minus 1. If this is 2, then this is 2 minus 1. Now, this is 3. What do I have here?
2 minus 1.
A2 plus 4, correct. Which is 16 plus 4, which is 20. Now, A4. What do I have to write for A4? Very good. A3 plus 4. So this is 20 plus 4, which is 24. We'll stop. Let's do one more, and then we'll stop after that. Let's say 18. We are given A1 equals 5, and we are given a recursive relationship, AN equals 3 times AN minus 1 and minus 1. And they say for n greater than or equal to 2, which we know. Okay, so we are asked to find the same thing. We're asked to find 4 terms, A1, A2, A3, and A4. Can anyone dictate A1? 5. Can anyone dictate the relationship first for A2, and then we'll calculate it? You will say 3 multiplied by, yes, A1 minus 1, indeed. So it is indeed 3 times 5 minus 1, 15 minus 1, 14. I agree. What will you write initially for everyone to see, and then we calculate? 3 multiplied by, very good, A2 minus 1. So now this is 3 multiplied by 14 minus 1. 3 times 14 is 42 minus 1, 41. Last one. What will you write for A4? Three times A3 minus 1, which is 3 times 41 minus 1. That's 123, 122. So this sequence was given to us using a relationship, a recursive relationship, and we were given A1. We were able to establish or find the other 3 using the relationship. This is the end.